All right, guys, let's come together here. Let's take a look. Shh. So the only transformation in number 3 you had to do was the vertical shift. So divisions along the x-axis are just like the parent function. Again, your baseline's at 2, and the a value is 1, so you're 1 unit above and 1 unit below the baseline. So any questions on number 3? Let's take a look at number 5. So I want to make sure we have time to do one with a phase shift. So when you take a look at number 5, first of all, what's the period in number 5 going to be? The period's going to be what? Pi. What's your phase shift going to be? Shh. Are we shifting it left or right? Right. To the right, pi over 4. Do we have a vertical translation? No. However, what other transformations do we have to consider? Well, you have a negative in the front, so what does that mean? We're going to have to do what? We have to reflect, and then we have a vertical stretch by 3, which again, that's what we've been looking at as the a value. So just like we've been doing with all these phase shiftings, again, we're shifting to the right here. So remember, the bookend method for cotangent is going to go from 0 to pi. So to find out where we're going to start and end this particular cycle, set up your inequality 0 less than x minus pi over 4 less than pi. So solve for x, I'm going to add pi over 4. So when I add pi to pi over 4, remember you need that common denominator, so that common denominator will be a 4. So pi is equivalent to 4 pi over 4 plus pi over 4, which will give me a 5 pi over 4. So any questions on how I solve this inequality? So now by shifting this graph to the right, pi over 4, I know this cycle is going to start at pi over 4. It's going to end at 5 pi over 4. So now remember, to find the midpoint between pi over 4 and 5 pi over 4, we add together and divide by 2. So pi over 4 plus 5 pi over 4 is a 6 pi over 4, which reduces to 3 pi over 2. Times a half, that's going to give me a 3 pi over 4. What's the midpoint between pi over 4 and 3 pi over 4 going to be? It's going to be what? So we pi over 2 is 3 pi over 4 plus pi over 4 is 4 pi over 4, which is pi. Divide by 2, that's a pi over 2. What's the midpoint going to be, guys, between 3 pi over 4 and 5 pi over 4? Well, if I add them together, that's an 8 pi over 4, which is 2 pi. Divide by 2, that's going to give me a pi. Jay, turn around, please. All the way around. All the way around. Thank you. So any questions, guys, with the divisions along the x-axis? Where's the baseline here, guys? The baseline's where? Where's the baseline? 0. My a value is 3, so I know those points will be 3 units above the baseline, 3 units below. Remember, I'm starting at pi over 4 for this cycle. Goes to pi over 2, 3 pi over 4, pi, and 5 pi over 4. Even though, ladies and gentlemen, I've taken this function and I've shifted it to the right pi over 4, when you graph a cotangent, just like a tangent, you are going to start and end with those vertical asymptotes. So I'm going to have a vertical asymptote at x equals pi over 4 and x equals 5 pi over 4. So now, remember, don't forget about your reflection. So instead of starting 3 units above the x-axis, I'm going to have to put my first key point 3 units below. Then it's a baseline, and then I'll go above the baseline to 3. And there's your reflected cotangent with the phase shift. So at pi over 4, it's negative 3, 0, and 3. So any questions on graphing a cotangent with a phase shift? Let's look at number 6. So So number 6 has a period and a phase shift in the same one. What's the period in number 6 going to be? What's the B value in number 6? Your B value is what? What's the B value? The B value is what? 3. So the period's going to be pi divided by that B value, so pi over 3. What are we going to have to do with this equation to identify the phase shift? Just like we've been doing for all of them, what do we have to factor out? We have to factor out a what? 3. So that's going to be x plus. We have to divide by 3 or multiply by a third, so that's going to be pi over 6 minus 2. So now what's your phase shift going to be? Am I going to the left or am I going to the right? Left. And my vertical translation, I'm going to be going down 2. So any questions on identifying the transformations? So now in order to figure out where I'm going to start and end this cycle, you want to set up the inequality. Again, for cotangent, it goes from 0 to pi. So 0 less than 3, x plus pi over 6 less than pi. So I first have to divide by 3. So 0 is less than x plus pi over 6 less than 3. Or no, pi over 3. What's next to finish solving this inequality? I'm going to have to do what? Subtract pi over 6. So negative pi over 6 less than x less than. Pi over 6 has to be subtracted from pi over 3. I need a common denominator. What's my common denominator going to be? 6. So that's going to be 2 pi over 6 minus pi over 6. That's going to give me a pi over 6. So I know I'm going to start this cycle at negative pi over 6. I'm going to end it at pi over 6. What's the midpoint? Midpoint's going to be what? 0. And then the midpoint between negative pi over 6 and 0 will be negative pi over 12. And then the midpoint between 0 and pi over 6 will be pi over 12. Any questions, guys, on how I got the divisions along the x-axis? Where's the baseline going to be? Your baseline's going to be where? Where's the baseline going to be? Negative 2. A value is 1, so I know I'll be 1 unit above, 1 unit below the baseline. So now I have my divisions. I've got 2 on the negative side, so negative pi over 6, negative pi over 12. 0, 2 on the positive side. Just like tangent and cotangents, parent functions, we're going to start and end with vertical asymptotes. There is no reflection, guys, so where's that first point going to be? Is it going to be above the baseline or below? Above. So at negative pi over 12, it's going to be up here at negative 1. At 0, it's a baseline, which is negative 2. At pi over 12, it's below, which is negative 3. So my vertical asymptotes are at x equals negative pi over 6, x equals pi over 6. So any questions, guys, on graphing the cotangent? You guys go ahead and see if you can do problem number 7. You write the equations of a cotangent just like you do for the tangent we did the other day. Jack, do you want to take the desk outside? Emma. Oh, 3 times is a charm. Hang on 1 second. So, ladies and gentlemen, remember, guys, just like we've been doing for all the trig functions, again, we're trying to put the equation in the form of y is equal to a times the cotangent of b times x minus c plus d. So you need to know your a, b, c's, and d's in order to write these equations. Remember, a is your vertical stretch or compression. So again, they're telling you that we have a vertical compression of 2/3, so I have to plug that into my coefficient of cotangent. Remember, you've got a phase shift of 4 pi over 3 to the right. So remember, it's going to be an x minus 4 pi over 3. And again, a reflection over the x-axis means cotangent has to have a negative sign in the front. Again, remember, it's not the period that goes into the equations when we're writing these equations. You've got to find your b value. It's always going to be pi or 2 pi divided by the period, depending upon what function you're trying to write it for. Tangent and cotangent have a period of pi from the parent function. So to find your b value, remember it's always pi divided by the period. So pi divided by 3 pi is a 1/3. So any questions on how I can write the equation for cotangent? So very similar to the way that we wrote the equations for tangent. Okay? All right, so your homework, guys, remember, is to do the 3.3 worksheet in your homework packet.